This section is 11.4, which is solving linear systems by multiplying first. So I want to make it clear that this is technically still the elimination method. It just has an extra step that we have to do. So if you remember our last section, 11.3, we used the elimination method, meaning eliminate a variable, but all we had to do was add or subtract them. Well, some of you asked in class, well, what happens if they are not the same? Like, what if it's not 2y and negative 2y? Well, that brings us to today, right? So what we will have to do is multiply possibly one or both equations by something to make them the same. So looking at our first example, your first step is to decide which variable do we want to eliminate. So obviously none of them are the same. However, we could do something to make them the same. So looking at both of these, hopefully we can kind of see that it might be easier to eliminate y. The reason for that is we could actually just multiply the second equation by 4, and that would make it 8y. Now, if I eliminated x, I would have to multiply the first equation by 2 and the second one by 3. That way they were both 6x. So I'm going to go ahead and eliminate my y. So this first equation, we don't need to do anything with. So I'm just going to go ahead and rewrite it as is. And my second equation, I'm going to go ahead and multiply it by 4. So when I do that, this turns into 8x. You have to multiply each part, minus 8y equals negative 40. Now this looks like section 11.3, right? So you look at, okay, I know I'm going to be eliminating my y's. Because they are opposite signs, I'm going to add. Remember, same is subtract, opposite is add. So 3x plus 8x is 11x. Those cancel. And 7 minus 40 is negative 33. And then we want to solve for x, so we divide by 11. Negative 33 divided by 11 is negative 3. So now that I have x, it's the same as it always is. You can plug it into either equation to find y. So I'll go ahead and use the top one. So 3 times x, which is negative 3, plus 8y equals 7. So this would be negative 9 plus 8y equals 7. And then I'm going to go ahead and add 9 to both sides. So we would get 8y equals 7 plus 9, which is 16. And then our last step would be to divide by 8, so we get y equals 2. So our final answer would be the ordered pair negative 3, 2. So this means if I were to graph both of these equations, we would have a point of intersection at negative 3, 2. So we're going to go ahead and look at another example. So this one's kind of a step up, because looking at this, I can't multiply negative 3 by an integer or a number and get 4, and I can't multiply 2 by anything and get 13. So that means we have to probably multiply both equations by something. Now, looking at these, to me, the x's seem a little bit easier to work with because 13 is a large number. So then we have to think about, well, what do 3 and 4 both go into? Like, what is a common factor that they have? And that would be 12. So I'm going to make them both 12. So you're looking for like the greatest common factor. So I'm going to multiply this one by 4. So when I do that, I get negative 12x, positive 8y, and positive 16. So again, it's important that you remember when you're multiplying by an integer, you have to multiply it by each term. Now this one, I'm going to have to multiply by 3. So this would be 12x, and then negative 13y times 3 would be negative 39y, and 5 times 3 is 15. So it's very obvious now that we want to eliminate our 12s because they are exactly the same. So because they are opposite signs, we are going to add them. So those will cancel, 8 minus 39y would be negative 31y. And then 16 plus 15 is 31. So that works out nicely. We divide by negative 31, and 31 divided by negative 31 is negative 1. So now that I have my y, I'm going to go ahead and plug that in to one of my x's. One of the equations for y. So this would be negative 3x plus 2 times negative 1 equals 4, which would be negative 3x minus 2 equals 4. Since I'm solving for x, I'm going to go ahead and add 2, which would get rid of that. So we get negative 3x equals 6. And lastly, divide by negative 3, and 6 divided by negative 3 would be negative 2. So the point of intersection would be negative 2, negative 1. So in other words, if I were to graph both equations, that is where they would intersect. Okay, as far as special cases, they are going to be exactly the same as they were in 11.3, meaning if you are eliminating something and you get 0 equals 0, then it would be infinite solutions. But if you get something like 0 equals negative 2, then it would be no solution. So the last thing that we are going to look at is modeling systems. So now we're going to kind of take our knowledge of how to solve a system of equation and create it and solve it from a scenario. So we have you sell tickets to a show. Student tickets are $8 and general tickets are $10. You sell 15 tickets total and make $132. How many of each ticket did you sell? So the first thing is we don't know how many of each ticket we sold, so that would be our first step to make those our variables. So x equals student ticket and y equals general ticket. Okay, now we're going to kind of look back at the information and see if we can kind of come up with a equation. So we know in total there were 15 tickets sold. So that means the amount of student and general tickets were 15. So that's going to be one of my equation is just for the, total sheer amount of tickets that were sold. We also know the price of the adult and student ticket, the general and student ticket. So we know that it's $8 per student ticket plus $10 per general ticket, and all of that together has to equal $132. So we just set up a system of equations. So at this point, you could actually use any method that you desire. So you can use substitution or elimination. I personally like elimination better, so I'm going to use that method. So I'm going to eliminate the y's. Now I can easily eliminate the x's by multiplying the first equation by 8, but personally I think that multiplying by 10 is just a bit easier because it's a nice number. So if I multiply this first equation by 10, I get 10x plus 10y equals 150. And then I'm just going to rewrite my second equation, 8x plus 10y equals 132. And then again, just a reminder, we are eliminating the y. So because they are the same sign, we are going to go ahead and use subtraction. So we would have 10x minus 8x, which would be 2x. Those cancel. And 150 minus 132 would be 18. We divide by 2, and x equals 9. Now we pick either equation to plug x into, but it's much easier in the first one. So 9 plus y equals 15. We should easily be able to tell what y is just kind of by looking at it, but I'm just showing the work. So y equals 6. So if I just wrote 9, 6, that didn't actually answer the question. So we have to look at the context of the problem. So x represents student tickets. So we would sell 9 student tickets and 6 general tickets. Okay, and then that would be it for that problem and for the section.